we are going to learn about sets, and remember sets just almost same to list, but one thing about sets is that sets are actually not immutable, but they are mutable. So you can change elements in between sets, and also sets also takes in different data types. So instead of maybe like only having lists, and it combines the strings, the doubles, using the same list. So the architectural way of declaring a set is just having your variable name here, and then assigning it into these opening and closing curly brackets. So that's actually the simplest architecture of a set, and we can perform actually different operations on set. So the first thing we're going to do is we're going to perform set intersection. Then we are also going to perform a set union. Then we are also going to check on symmetric difference in sets. And also the last thing we might like check into. So we have intersection, unions, and symmetric difference. So those are actually the basic three operation in sets. So let's start by maybe creating first an empty set. So you're going to say just my set. Then that's the basic architecture of printing a simple set. So if I'm going now to run my set, you find that it's printing just an empty set. So we can add elements here. So maybe you have a 2, 4, maybe let's say we have a string here, teams, then we have a boolean here. So let's say 4.5. So if you now run this, you now see that we have elements here. So by default, when it comes to the order of actually the set, so you start with integers, then followed by doubles. Then if you have strings, it's gonna follow. So let's say we have a boolean here. So we have true. So let's see what will be printed. So you now see that it's going to start with actually the boolean. So it starts with booleans, then because it only has two values, so it's just say that true or a false. So the next thing maybe we want to like focus now is we can actually create a list inside a set. So instead of actually like creating maybe like my set, my set, then now giving it for the other case I was using actually like the camel case naming. So let's actually learn to use the underscore one. So if actually especially values are not booleans. So let's say my set here, so maybe I have a list here. So let's say I have a list of even numbers 2, 4, 6, and 8. Then actually I want to convert them into a set. So this you would think this is the right way, but if you now run this, let's see what will happen. Type error unhashable. So list the compiler will actually throw in an error saying that our lists are unhashable. So to actually convert this into a set from a list, you have to use the set method. So you go for the set, then let me just clear my output here, and then you now run. So you can now say print my set. So if you now run my set, you now find that we have these elements. So we have 8, 2, 4, and 6. Sorry, I'm not sure if I mentioned this, but sets are actually an ordered list. So the way items are going to be printed comes in different order. So it prints items which have actually have no order. So maybe let's check on iteration. So we're going to check if an element actually truly exists in maybe a set. So let's say we have this set here. So let's say we want to actually check if an element exists here. So we're going to maybe like just use a simple if statement. So we're going to say if now 2 in my set. So then we're going to say print yes. Then the next thing, let's go for else. So else print, let's say no such element. So if we now run our program, then we expect this output will be placed here. So it's actually telling us that 2 is in the list, in the set. So we can also like just instead of using all this line, then we can directly use the printer method. So you can just say print 2 in So this will actually like return a boolean. So print 2 in my set. So we're going to run this, then it returns 2. So what happens in a case where maybe you just try like run 0? So if you now run that, you now see that our output is actually false. So let me just clear this so that we can actually go into the last part of actually this. So we can again maybe like print these elements, so using the iteration. So for iterating elements, remember we talked about using the for loop. So I'm going to go and say for my set. Oh no, let's just for elements, let's give it a variable name for elements in my set. Then going to say print the elements. So just going to remove this one here. Now if I run this, then we now see that we are printing these different elements. If we now run it again, you now find that it's still printing the same thing. So items come without any order. So the way you've ordered them here doesn't actually like have to necessarily match with the way you are printing them on the final part. So one more final thing. So let's say we now have numbers. So let's just say we have set A, and then assign it elements of maybe like 1, 2, 3, 4. Yeah, let's say 5 here. Then we have maybe set B. So set B, we're going to assign also some elements. So let's assign it from again 4, 5, then 6, 7, and 8. Now let's perform some of the basic sets operations. So to do that, so let's print this. Then we'll be explaining it based on our output. So let's perform the first thing you want. Let's just perform with set union. Then you're going to say, so for union, for set union, actually it uses okay, let me just let me not write over here. So A set B. So it uses this sign here. So if you now run, it prints a collection of items, and if you actually note this very close, it's printing all the elements and removing repeated elements. So we have 4 and 5 repeated in set A and set B. So but on our output now we have 1, 2, 3, 4, 5, 6, 7, and 8. So what actually the set union is, it removes duplicate elements. So this is actually one of the most one of the most required and basic thing when it comes to like programming. So the next thing we want to perform is let's perform set intersection. So for intersection, we are going to use the AND operator. So it's going to clear my output here. Then we're going to run it again. Now we see that we have 4 and 5. So what actually the intersections does is it prints repeated duplicate elements. So the next thing maybe you want to look at is we want to look at the symmetric difference. For symmetric difference, it actually uses the minus symbol. So if you now run this, it actually, so I want you to like note it very close. So it actually prints the elements in A and leaves out the elements that are not in actually set A. So it's leaving 4 and 5 because these are duplicates, and it's also leaving 6, 7, 8 because these are elements that are not found in A. So what happens if you now change this to set B A? So let's run. You now find that it's printing 8, 6, and 7. So it's now printing the elements that are in actually set B and leaving duplicate elements and also elements that are not in set B. So that was actually something very interesting. So the next thing we want to do is symmetric difference. So the symmetric difference uses actually the raised I don't know. So we call this one maybe the power in maybe like mathematics. So let's run it and see what will be printed. So let's first start with set A, then we are going to check on set B. So once we have that, I'm going to run it. So it's now printing 1, 2, 3, then 6, 7, 8. So it's 1, 2, 3, then 6, 7, and 8. So I'm just going to like do this. So it's now printing these elements here, leaving repeated elements. So the other way also, it's going to be the same scenario. So we're going to print here then run the output. You now still find the same case 1, 2, 3. Then so now the symmetric difference one doesn't like include the order. So if you start with A or B, then A and B, then it's not going to like follow your specific order, but it's just going to print still with the same actually architecture. So that was actually like one of the most basic things about it.